Hey, everybody. Today we're going to be talking about writing chemical reaction equations. So, let's get started. First of all, let's start at the beginning. What is a chemical reaction? Well, a chemical reaction is a process by which one or more substances get rearranged to form new substances. Now, note that nothing is being created or destroyed in this situation because just like any other process, a chemical reaction has to abide by the law of conservation of mass and the law of conservation of energy, which basically means that no mass or energy can be created or destroyed. So even though sometimes what you end up with at the end of a chemical reaction looks and in other ways is very different than what you started with, it's really just a rearrangement of the atoms that were there to begin with. It's nothing new. So, when you're writing chemical reactions, there's two sides to the chemical reaction. There's the reactants and the products. The reactants are what you see on the left-hand side of the chemical reaction, and there's an example reaction down here for you to look at. So, SO2 and O2 are the reactants in this situation. They're always on the left, and they are the things that you started with, the things that you mixed together to react. On the right-hand side are the products. So, in this case, SO3 is the product. Those are the substances that are formed. Now, you might notice that there are some numbers in front of some of these different compounds. Those are called coefficients. So, a coefficient is a number that represents how many of each reactant or product are involved in the reaction. In the next video on balancing chemical reactions, you're going to understand where those come from and how you can know what they should be. Now, note that if there's ever not a coefficient, like you see here, there's no coefficient in front of O2, that's an implied 1. Chemists are just lazy. For some reason, they don't like to write ones. And so if you ever see no coefficient, it's an implication that there is just one of those compounds. It doesn't mean that there's none of it. Now, some other things to note. You will also see sometimes, not everybody does this and they don't do it all the time, but sometimes you'll see letters written in parentheses as subscripts next to compounds. Like each of these has a G next to it. If you see that, those represent the state that that compound is in. So if you see an S in parentheses, it means that that thing is in a solid state. If you see an L, it's in a liquid state. And if you see a G, it's in a gaseous state. If you ever see AQ, it means it's in an aqueous state. And aqueous just means dissolved in water. So you could, for example, have aqueous NaCl. NaCl is salt. And so that just means that the salt is dissolved in water. And that's the state that it's in going into or coming out of the chemical reaction. There's also some notes over here about other symbols you'll see. The pluses are pretty obvious, but it's really important to note that in these chemical reaction equations, there is no equal sign. That's one of the most common mistakes that people make when they're starting this is they'll do this plus this equals this. That's not how you write it. You always write an arrow where you might think that an equal sign would go, because that shows that the reactants are turning into the products. If you put an equal sign, you're just saying those two things are the same. They're not. One is changing into the other. It's an important distinction. Also, sometimes you might see a double sided arrow, and that simply means that the reaction is reversible. It could go one way, or it could go the other way. And oftentimes, what determines which way it goes is not only what you're starting with, but also an energy change. Usually, one way will release energy, whereas the other way takes energy, an input of energy to make it happen. But you might see that sometimes as well. So, the goal here is for you to be able to either look at a chemical reaction and write down or say out loud that chemical reaction. It's really important for communicating within a chemistry lab or with between chemistry colleagues. You should also be able to go the other direction. If someone tells you what a chemical reaction is, or if you see it written on a piece of paper, you should be able to write a chemical reaction formula for that. So for example, if I were to see this reaction here, the way that I would say that is I wouldn't say Al subscript S plus Br subscript 2 subscript L arrow AlBr subscript 3s. That's super clunky and awkward. What you would say is solid aluminum and liquid bromine react to produce solid aluminum bromide. So, I want to give you a chance to try going in the other direction. So I'm going to pause and stop talking for about 5 seconds. And I'd like you to pause the video and try to write these chemical reaction equations as equations from them being written out as sentences. So go ahead and give it a try. All right, I hope you gave that a try. I'm going to show you the answers now and talk you through them. So the first one, gaseous hydrogen and liquid bromine combine yielding liquid hydrobromic acid. So this is the chemical equation for hydrogen. Since we know it's a gas, we're going to put a little g in parentheses after it as a subscript, plus liquid bromine. So this is bromine. And sorry, I messed that up. That should be an L there, not a G. I apologize. That's my mistake. Those react to form hydrobromic acid, which is in a liquid state. Now, notice that in order to do this, you are going to need to know your compound nomenclature. You're going to need to know how to write ionic compounds, covalent compounds, and acidic compounds. You need to know how to go from their names to formulas, and you need to know how to go from formulas to names. That's a really, really important, vital skill, and you really, honestly, can't move forward in chemistry without knowing that. So, if that is a struggle for you, make sure to do some review soon. And we've posted some review videos that should help you, as well as some review practice. So if you need the review, please make sure to do that so that you aren't falling behind as we move forward with Chemistry B. All right, example number 2, carbon monoxide gas and oxygen gas react to form carbon dioxide gas. Again, you need to know nomenclature in order to know how to write carbon monoxide and carbon dioxide. Carbon monoxide means one carbon, one oxygen, and since it's a gas, we'll write a G under it as a subscript. Oxygen is O2, and it's a gas, and that reacts to form, so you put an arrow, and it's reacting to form carbon dioxide gas, which is carbon and two oxygens in a gaseous state. So that's how that should be written. Now, there's really only one other thing that I need to point out before I end this lecture, and that is these twos here. How do I know that there's a 2 after hydrogen and bromine and oxygen when there doesn't seem to be anything in the written formula that indicates that, right? Gaseous hydrogen. How do I know that there's 2 hydrogens there? Well, if you haven't learned this yet, it's important to note that there are 7 elements that we call the diatomic elements. They're hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now, what makes these special is that most elements exist or can exist as single atoms floating in space, right? If you just have an iron atom, that's fine. Iron atoms can just float through space on their own. But there are seven elements that you don't ever find alone. And those are the ones that I just listed out. They're called the diatomic elements. They will always pair up with another element or another atom of the same element. So a hydrogen will always find another hydrogen, nitrogen will always find another nitrogen, etc. You kind of just need to memorize these, to be honest with you, because if you're ever writing a chemical equation and it just says that nitrogen is one of the reactants, you need to know to write N2 and not just N, because that's going to alter and drastically change something called balancing the equation, which is the thing you're going to learn about in the next video lecture. So it's really important that you remember these. But I don't necessarily want you to just memorize them without any other tools. Here are a couple things that you can use to help make that memorization process a little bit easier. First of all, if you're a visual person, you can think that these 7 elements make a 7 on the periodic table, right? Starting with nitrogen, going to fluorine, and going down to iodine. Those are the 7 diatomic elements. The only thing with that is that you also have to remember that hydrogen is also a diatomic element. So it makes a 7 on the periodic table plus hydrogen. Those are the diatomic elements. The way that I remember them, and the way that I think most students choose to remember them, is using a helpful mnemonic device. So if you just say to yourself, I have no bright or clever friends, that is a mnemonic where each word starts with one or two letters that indicate one of the diatomic elements. So I is iodine, have is hydrogen, no is nitrogen, bright is Br, bromine, or oxygen, clever is chlorine, and friends is fluorine. Now you could even come up with your own if you wanted to. You could come up with a different mnemonic device that starts with those same letters that helps you remember the diatomic elements. It's really up to you. But the one thing I want to make sure is that as many times as you say, I have no bright or clever friends, just don't say it so many times that you start to believe it. All right. Because I don't want to do that to you. And that's really what you need to know about writing chemical reaction formulas. So please let us know if you have any questions about that. And this is going to continue on into the next lecture about balancing chemical reactions. So watch that one right after you watch this one. And until next time, take it easy.